Hello. Hello.
Hello.
Hello.
Ma'am, you are audible. You are audible, ma'am. Hello? Hello? Ma'am, am I audible? Hello?
Hello. Hello.
Hello.
Can you hear us? Hello, ma'am?
Yeah.
Ah,
Yeah. Hello. Hello. Am I audible,
Hello.
ma'am?
Yes, yes. You are clear,
Okay.
ma'am.
Fine.
Your voice is clear. Audible. Okay. We will have the
Okay.
session in
Okay.
5
Fine.
minutes, ma'am. Only 5 minutes.
Okay. No issues. Okay.
Hello? Hello? Ma'am, am I audible? Hello?
Hello. Hello.
Hello.
Can you hear us? Hello, ma'am?
Yeah.
Ah,
Yeah. Hello. Hello. Am I audible, ma'am?
Hello. Yes, ma'am. You are clear,
Okay.
ma'am.
Fine.
Your voice is clear. Audible. Okay. We will have the
Okay.
session in
Okay.
5
Fine.
minutes, ma'am. Only 5 minutes.
Okay. No issues. Okay.
Hello? Hello? Ma'am, am I audible? Hello?
Hello. Hello.
Hello.
Can you hear us? Hello, ma'am.
Yeah. Yeah. Hello. Hello. Am I audible, ma'am?
Yes, ma'am. You are audible.
Okay, fine.
Your voice is clear. Can you share your
Okay.
screen
Okay,
so that we
fine.
can check before we start?
Yes.
Okay, no
Yes. Yeah.
issues.
Yes, ma'am. I'll share the screen. One second.
Hello. Ma'am, am I audible? Hello.
Yeah. My screen is visible, ma'am.
Yes, ma'am.
Hello. Okay. So is it a slideshow? No, full screen.
Yeah, yes.
Okay, fine.
Hello. Hello.
Ma'am, there are certain participants who are joining online as well as we have students and faculty here who are joining physically. Okay, so you'll be having both the participants.
Okay. Hello.
Yes, ma'am. Can you hear us?
So let me know when should I start so that I can
hello,
turn on my camera
hello,
also. Am I audible, ma'am?
Yes, ma'am. You are audible.
Okay, fine.
Your voice is clear. Can you share your
Okay. Okay,
screen so that we
fine.
can check
Okay.
before we start?
Yes, yes, yeah, yes, ma'am. I'll share the screen. One second.
Hello. Ma'am, am I audible? Hello.
Yeah. My screen is visible, ma'am.
Yes, ma'am. Ma'am, can you switch on your video?
Yes, ma'am.
Hello.
Hello, ma'am.
Okay. So is it a slideshow? No, full screen.
Yeah, yes.
Yes, it
Shall we
is, ma'am.
start? Okay,
Ma'am,
one
can you
second.
switch on the video once?
Yes, yes, I'm doing. Is it visible now?
Yes.
Okay, fine.
Hello. Hello.
I think my system got hanged. One second. My system got hacked. So one
Ma'am, there are
second, I'll
certain
just check.
participants who are joining online as well as we have students and faculty here who are joining physically. Okay, so you'll be having both the participants.
Okay. Hello.
Yes, ma'am. Can you hear us?
So
Now we are
let me
going to
know
start the
when
session.
should I start so that I Yeah, can hello.
Yes.
Turn on my camera
Hello,
also.
am
I audible, ma'am?
Yes, ma'am. You are audible.
Okay, fine.
Your voice is clear. Can you share your
Okay.
screen? Yeah, I welcome all the participants once again for the plenary talk 2.
Okay,
So that we
fine.
can check before we start.
Yes, yes, yeah, yes, ma'am. I'll share the screen. One second.
Hello. So shall I start? Ma'am, am I audible? Hello.
Yeah. My screen is visible, ma'am.
Yes, ma'am. Ma'am, can you switch on your video?
Yes, ma'am.
Hello.
Hello, ma'am.
Okay. So is it a slideshow? No, full screen.
Yeah, yes.
Yes, it
Shall we
is.
start? Am I audible
Ma'am, can you
and
switch on the
visible?
video once?
Yes, yes, I'm doing.
Ma'am, are you ready now?
Yeah, I'm ready. Am I visible and audible both, right?
Yes, yes, you are. Okay.
Okay. So I
So,
think we should start then.
yes, yes. So, we are going to start our second session on artificial intelligence in wearables. It's a plenary talk too by Dr. Princy Randhawa. I'm going to introduce her. Dr. Princy Randhawa is an assistant professor, senior scale in the Department of Mechatronics Engineering. She has been associated with the Manipal University, Jaipur since July 2015. She is also an assistant director in the Directorate of Alumni Relations. She has over 10 years of teaching and industrial experience. Her fields of interest lie in research topics like control systems, machine learning, etc. She has published more than 30 research papers at various international conferences and journals in the finest area of her research. She has published 9 papers in SCI journal, out of which 3 are in Q1 journals. She has a good publication record with 4 patents and 1 copyright on her research. She is a professional member of the International Society of Automation and senior member of IEEE. Recently, she has also presented the paper at Worcester College, University of Oxford, and for that she received the travel grant from SERB. She is also an active member of various NGOs and conducted various cancer awareness and women sanitation hygiene programs in rural colleges. She has also delivered many invited talks on different platforms. Manipal University Jaipur's illustrious leadership bestowed upon her the MUJ All-Rounder Award 2022 in recognition of her dedicated teaching, administration and research, and Young Researcher and Professional Excellence Award in 2023. With this, I request Dr. Princy to take over the session.
Thank you so much, ma'am, for the introduction. And first of all, I want to thank to the organizers for inviting me here to give a talk on a very special topic. That is my favorite topic. So I'll be talking about the artificial intelligence in women safety using wearables. So, in simple words, if I can talk about, you can say this we are how we are using this smart technology uh, to keep women safe. So you can see like there are different kinds of like gadgets here. There are different kinds of technologies that we are using for the women's safety. So today we'll be talking about that technologies also, and also the different technologies which we will be focusing on. So so my talk will be focused on you can say it's a innovative amalgamation of artificial intelligence and wearable technology. So what we see is like now wearable devices we see just like as a gadgets, but how can we use this gadget as a powerful tools for the safety, and how we can integrate this variables into how we can integrate this artificial intelligence into this variables. So I'll be talking about this in detail, how we can integrate, what kind of algorithms we use, what are the different applications and all. So before we start, I just want to start with this one quote that say peace is not the absence of conflict, but the presence of creative alternatives for responding to probable conflict. So what I want to convey through this quote is like it's not having conflict that is going to assure peace or the state of no violence. So this violence and conflict will always be there. So what we need to do is like what we have to aspire is to create something alternative response so that we can use this for the women's safety thing. So this violence will always be there. So in this topic, in this my talk, I'll be talking about the system which will act as a deterrence, and which will a system which will practically eliminate, or you can say like 70% violent assaults that can we can remove. So in this system, I'll be talking about also how we can differentiate between the complex activities and the normal motions and all. So how we can use those algorithms. So, like first, if you see this survey, we all have heard about this Nirbhaya case, which happened. Unfortunate incident happened few years back, which shook the entire world, not just India. So what I did is after that incident, I start collecting the data and try to understand that how has it happened, why has it happened, and if you see like the survey thing, it says like according to NCRB, that every 15 minutes, one rape is reported in India, but only 85% that led to charges and 27% it's led to convicted. So what happened to that 73%? How do you that they have not been conducted? How will you come to know that? So what is the reason why they are not being able to convicted? So that we will be talking about, like what kind of technology and what are the like gadgets are available, how we can use this AI into this variables and all. So first of all, okay, so in the last slide we have seen like why that thing happened, and we need to understand. So is there any system like could it be a lack of evidence or the need of the system which could provide a quantified data or something which we can report it? So like anything happens, like assaulted thing happens, like so we need a system, some you can say foolproof system. It should not be like okay, if the woman is being attacked, so she or like any if it's not I'm talking about the woman, this can happen with the like children also, like or any person. So it's not like that person has to press a button if anything happens, right? So it should happens automatically. So it should not require a human trigger, right? So that the gadget itself should provide a stretch or pressure or position or orientation or some kind of location of the data. So that gadget should be a quantifiable data of physical motion. So in this, we were interested in something building which can quantify and act as a deterrent system, especially for the women. Hello. Hello. Can you just like mute? There is a noise. Hello. Hello. Okay. Yeah. So so that gadget should be a reactive system against any physical movement. So we have seen like there are different kinds of research and different kinds of gadgets are already created for the protection of women. You must have heard about the pepper spray, safety torch, smart pendant, smart jewelry. So there are hundreds of products are available already in Amazon. So what is the new thing we are doing here in this research? So I'll be talking about that. So if we talk about the women's safety, the survey shows that only there is 9% of Indian women feel public transport is safe. So what about the 91%? So 91% of the women across cities, they think that the public transportation is unsafe, and like there is no proper safety is there when they like we have seen like a lot of cases also in the transportation and transport also. So in the even in the administration part also, we can see like our government has done a lot of like they have developed a lot of apps also for the women. Like they used one app like that they launched in 2015 by our home minister. So there are some lot of efforts have been going on, but still we have not seen any results happen. Still a lot of these activities are happening. So, so I have talked about the different gadgets. Also, you can see there are different apps and already available SOS button, safety pin, Shiros, Smart 24/7, Himmat app. So there are a lot of apps are already available. So I'll not talk about this. You can just go through these apps for the women's safety. And there are a lot of gadgets like your safelet, paper spray pistol, lipstick, flashlight, safety rod, sonata watch, pendant. So there are different kinds of these gadgets are available. But what is the difference? Like in all these gadgets, what we need to is if anything happens, so the person has to trigger the button. But in that condition, the person will be like the victim will be person will not be in that position so that he or she can that press the button. So that is why we need some system which will react automatically. So that is why this your variables comes into a picture. So what is this wearable technology? So wearable technology, you can say it's that is we design that we can worn on the body, which consists of your electronic devices, which are closer to the surface of your skin, which can detect or analyze and transmit various kinds of information. So we have heard about different kinds of gadgets also into this variables. So you can see in the picture, there is a skin patch which is we use to measure blood pressure. So also there is the latest technology I've seen in the latest last night only there was a one video on electronic skin. So that can be which will stick to the surface like your meeting. Hello. Hello.
Yes, ma'am.
Yeah. So you can see this electronic skin which will stick to your skin like a bandit, and which contains sensors which will measure your temperature and pressure and even your stress level also. And even I have seen one technology like they're using this e-skin which can be used to send alerts to the user or emergency contact when there is any abnormal patterns or anomalies are detected. So there are a lot of technologies, there are a lot of developments have been there are a lot of things are happening. So, and there are a number of projects also which have been doing using this smart fabrics like your Wealthy, Marmoth, Biotex, Utop, Microfix, Avalon. So basically, if I talk about one of this project, so there is a in this projects your fabrics that will be embedded with sensors which will detect your like there is one project which will control the lighting, your music or any kind of parameters. So there are different kinds of smart fabrics are available. So there is one more smart fabrics. There is a Jacquard project which was developed by both Google and Levi's. So what they do is that is mostly for your cyclist persons they are using. So they can take the calls, they can change the track of a music and all. So everything is embedded into your fabric itself. So now why I am talking about this and how these variables will be helpful for women's safety. So I'll be talking about in my further slides. Okay, now fabric to smart fabric. So how can this simple fabric can be converted into a smart fabric or e-textile, or you can say smart uh, garments? So when all your electronics and interconnections are woven into the fabric itself and can interact with the environment, and there is a eliminations of the wires and all and complex electronics components, so that we can call it as a smart fabric, and all the sensors are embedded onto the fabric itself. So these smart like I'm talking about the smart textiles, these are integrated, you can say it's almost all the fields of applied science, whether it's electronics, your material science, your optical fibers, even artificial intelligence, which I'm talking about, organic chemistry, biotechnology, aviations, communications, everywhere now this technology is this developing in this field. So now the question is how to incorporate all these sensors into the clothing and make it smart textiles and all. So you can see in this figure, fabric sensors we are using here. sensors like your pressure sensor, your stretch sensor, your accelerometer, which will monitor all your physiological variables or any kind of other variables like your heart or your breathing rate. And the second component is your family of your conductive elastic yarn, because how we can connect those sensors, how they will communicate with each other. So instead of wires, we are using here a conductive thread. So, and then third component, that is consist of your processing unit. So once the data will be collected, how we will process it and process the data from the sensors. So that is the three main components of your smart fabric. Now, if we talk about the history of your wearable technology, you can see it started like long back in 1600s, abacus ring. So this start is still 2014. Now, if we talk about 2024 and all, we have seen like a lot of smart textiles, which I'll be talking about in the next slide. A lot of smart textiles are already coming. It's already in the market, and what they do exactly. So we'll be seeing in the next slide. Okay, so what are the different applications? You can see here during the COVID time, everyone was wearing a mask and all, but the problem was that there was, you can see like the people who were using mask for a prolonged time, they were started having a headaches, rashes, acne, and even skin allergies also. So then there is I don't remember the who has developed this, but they have come with this wearable like your AO Air's Atoms air mask that uses a combination of your filters and your fans, which automatically clean the air which you breathe. So you can see this is already available in the Amazon. So this is also a kind of your wearable technology, and also it will also a great way to protect yourself from your even harmful pollution also that we can use. There are other different application apart from your health care. So like that also in your safety, your security, your surveillance, also in your education time, education also. So there are different applications which we are using under this wearable technologies. Oh, okay. So focus, if we talk about the market and if we do market analysis, you can see after the COVID, so this wearable technology has expanded especially in the health of your in the area of your health sector. So like you can see in the pie chart, so how they are using this wearables, like you're in some using in the form of your lifestyle, fitness, medical, and where they are wearing this technology, whether they are worn on your arm, body, feet, legs. So you can see it's everywhere now. You can see this wearable technology. Okay, now we come to our main thing, how we can use this wearable technology for the women's safety. So I was talking about when something happens, some assault happens or something violent attack happens to the woman. So during that short struggle, so when she tries to escape, so what she cannot press the button or something, like only the fabric which is worn by the victim, it will undergoes a different degree of your stretching and compression, right? So that is the thing which we want to record, and for that we need some kind of fabric which has your pressure sensor, your stretch sensor, and your orientation sensors. Now the thing is, you can see here both the pictures, the movement is same, right? So in first picture, the woman is dancing, and the another picture, it is the woman is being assaulted, right? So how can you differentiate these two complex activities, right? So that then artificial intelligence comes into picture, so which will classify your complex human activities between your normal activity and your resistance to assault. So this is the like how we can take the data from the sensors and how we can use this AI techniques and what kind of algorithms we will be using. So I'll be talking about that. So this is the main challenge. Okay, so in the previous slide, I was talking about the smart fabric, which is already available for the women's safety. So there are few, you can see smart fabrics here like Shield Tex, Dress for Success, Safe Skin, Tela Sensor and all. So if I talk about Shield Tex, so what they did is this is a fabric that is embedded with your conductive thread and which will create an electric field and if that cloth is being touched, the field will be disrupted and that alarm will be triggered. So this is the one kind of that fabric which we have in the market for the women's safety. And then another dress for success that is equipped with the GPS tracker and your panic button. But again, the same thing like panic button, we in that position that woman cannot, like she cannot press a button, right? So that is and then third is your safe skin. So it is also that fabric is also equipped with the some kind of reflective strip that makes the this wearable visible at night also. And then tela sensor that again when it comes in contact with the water or your blood or something, so it will again trigger an alarm. So there are different kinds of fabrics which is already available for the women's safety. Now, so we were talking about our application, how we can embed, embed those sensors into the this fabric, right? So first is how we have to identify the areas where the sensors can be placed, and then we can do some hardware implementation of the jacket or any kind of cloth, right? So how the data is collected from the sensors. So we need to conduct various experiments first to differentiate between these activities. And then finally, the software architecture of the jacket where the model will be deployed and using the different algorithms. And it will be evaluated on the basis of your accuracy, your precision, and your speed. So first step is sensor placement. Our first objective is to place a sensor on the jacket. So the survey, according to the survey which we started, you can see these were the positions which gives the highest mobility, right? During the movements, it was your shoulder blades, your elbow, and the wrist. Now you can see here is Flora microcontroller. That is where all the data will be stored. And mainly this is microcontroller is mainly for your fabric itself, not for other applications. So you can see we have used different kind of stretch sensors, your pressure sensors here for the orientation and the body movements. So hardware of the architecture. So to build the prototype of this, first is to integration of your fabric sensors with your embedded computers and your technical problems directly. We cannot integrate those sensors onto your fabric. So there are a lot of problems you can face to get a flawless and smooth integration of your smooth data collection for your classification of this attack sequences. So you can see here we have used on elbow we have placed elbow this stretch sensor and your pressure sensor. On the right hand also we have placed stretch sensor and pressure sensor and shoulder blade also. And on the chest we have used this Flora microcontroller which all the data will be stored. Okay, so now you can see here these are the components which is for your fabric. So we have used accelerometer also, that is for the orientation, and this is the Flora, that is your processing unit. And you can see here how we can how we have integrated those sensors using a conductive. There is no there is an elimination of wires. We are not using any wires. There is a conductive thread which can be used to connect these sensors. And we have this Flora accelerometer, which is you can say it's a 9 degree of freedom accelerometer, which has your accelerometer, your gyroscope, your magnetometer, which will provide your motion and the direction of your subject. And this Bluetooth. So once there will be some patterns which we detect, so that data will be directly go to the module, to the device through your Bluetooth. Okay, so next is here. Okay, now next, how we can collect the sensors, how we select the sensors, what kind of pressure sensor, what kind of stress sensor which we can use. So based on the literature survey, it was created. We need to select the different kind of sensors. So you can see there is some experimentation has been done. So the sensors response was studied. So we have like done experiments with different kinds of fabrics. So these are the two fabrics which we have studied, two characteristics of your linearity and repeatability. So the first fabric, which is you can say it's a composition of your silver nylon 16%, rayon 84%, and the fabric two again 76% nylon and 24% elastic fabric. So what is the difference? You can see in the first fabric, as we are stretching the fabric, your resistance is increasing, right? So at one point, it start decreasing. So according to the experimentations, we have come to know, okay, fabric 2 is like both the characters linearity and repeatability. It shows the good results. So we have selected this sensor, stretch sensor. Now, how we created this pressure sensor? This was handcrafted using your again pressure sensitive fabric, and you can see here we have used this conductive thread and we use conductive fabric. So, which will this is the pressure sensor which will detect the pressure, and it is type of pressure sensor which will, you can say, it's a type of fabric that changes its property when the pressure is applied. So it will detect your if like if someone is if the person is being attacked, so that compression of your fabric and that will be there. So it will detect the data. Okay, now creation of the bus lines. Okay, we have used the conductive thread also, but that conductive thread did not work did not uh, work actually in our this experimentation. So we have created a bus lines. So it was because why actually it didn't happen. The resistance which was offered per meter by the thread was so high, which was leading to there was a reduction in your conduction area and the quality of your and we were not getting the good results also. So that is why we have conducted our own bus lines using this conductive fabric. So which was giving the more which was giving a good results in the in terms of your linearity and your repeatability. So this was the circuit. This is a circuit diagram which was created in a software using Easy ADA, and there are different kinds of softwares for your circuit design and your circuit simulator. And you can see here what you're looking here is a circuit. It has a processing unit which combines with the Flora chip, Bluetooth, and the resistors, which will measure the resistance because of the change in the sensor properties, which you can see in both the sides here. And left and the right part in this picture. If we zoom into this picture, this is, you can see the circle one, this is your Flora chip. And we have on the left side, you can see it's a multiplexer, which will select which input we're going to select. And these are the resistors and the sensor data, which is coming from these lines. So, and here we can use the lithium ion battery and the Bluetooth, which is going to talk with the app, and the Flora, which process all your pressure and your the stretch sensors. And this is the data acquisition model, and which is presented in this figure. And the You can see here the one which I showed you, that is the same one here, the different components for the collection of the data, and which pins we have used for your acquisitions, where we have connected this pressure sensors, your module, your resistors and all, and multiplexer. Okay, now we have a data now. So how we will deploy the model now? So there are two questions here. You can see here, for one is your control experiment and uncontrolled experiment. So in the control experiment, we give the instructions to the subject. Okay, you have to walk like this. You have to perform activity like this. So, but in the uncontrolled experiment, it's a real-time data. We are not giving any instructions or range like, okay, so the person can do the activity on their own. So, and another is your, the subject is only one type. In uncontrolled experiment, there will be different kinds of subjects which will be engaged to generate the data. And so if we, so before deploy the model, now we have the data. So how we can deploy the model? What are the different process for recognition of this normal and the complex activity? So you can see here, we have 15 different classes, right? We have, if we talk about the accelerometer, we have like magnetometer, we have your accelerometer, sorry, this gyroscope, magnetometer in X and Y and Z direction. So that is your 9 degree of freedom. Then again, pressure sensor XYZ direction, stretch sensor XYZ direction. So we have 15 different classes. So then first step is to be follow that we have to load the data from the sensor, and then second is to pre-process the data. So for the pre-processing, we check for the outliers, data points that will lie outside or rest of the data, or also the missing values, which will reduce the size of the data. So after that, we divide the data set into two parts, and that one will be used for your testing and rest of the data for your training to build the models. And also we also call it as a cross validation technique. And then third is your feature selection and your feature extraction. So in this method, we are turning the raw data which we are getting into some meaningful information, so that we can use the machine learning, we can use the different algorithms. So when we apply this machine learning and artificial intelligence, so most of our time is spent in your step 3 and step 4. That is your feature selection and your feature extraction. So if we are getting if we're selecting the correct features, so we'll get the good accuracy. So and then finally we will apply that model. Okay, so now the next is performance metrics. If we talk about our application, so how we can evaluate the model? So that through your confusion matrix, so that is used to describe the performance of your model. And you can see here in this, we have two classes. One is your attack and your normal. So first is your true positive. So so if the person is being attacked, it is showing attack. That's a okay. That's a fine result. But if the person is being attacked and it is showing normal, so that is your false positive. And if it is again, if it is normal and showing attack, that is again a problem. So our true positive and your true negative, that your cost of your false positive should be more than your cost of your false negative. So attacked is predicted as a normal. So that is should not be there. So that is your uncorrected classification. So there are different parameters. You can say accuracy, recall. So we again will be using this for our model also. I will not talk more about this. So yeah, so this is the confusion matrix which the data which we have collected. In this, you can see we have used different kinds of activities, A1, A2, A3. What is actually this? A1 is like simply the person is sitting. A2 is your person is walking. A3 is like person is, that is your transition movements from sitting to standing. And lastly, that A6 is your when the person is being attacked here. So there are 6 activities which we have classified here in this application. So if you see the results here, you can see the various algorithms which we have used for the classification in your controlled environment. So in the controlled environment, what we were doing is we were instructing the subject to do that kind of activity, and that's okay, you have to walk like this, you have to uh, perform an activity like this. So in this we are instructing, so you can see we are getting accuracy, good accuracy. If you're using this simple mostly used algorithms, you can see SVM was giving the best results. Now what happens if we take the real time data, if we classify this in an uncontrolled environment? So you can see here the accuracy has been decreased here where if we're using the same algorithm, that is here 83.9%. So these are the techniques which we can use for the classifications. We have different kinds of algorithms, but these are the most commonly used algorithms. And we did the same few professors also. If anyone interested in doing such kind of projects, so they can contact me.
Yes, ma'am. Ma'am, can you share your contact details here so that they can
Yeah.
contact you?
So I'll just think there is not an option here where I can message.
Uh,
Yeah,
else,
I'll share the number and my email ID.
yes, please. Okay. I hope this is the end of the session, ma'am, as there are no questions. Ma'am, thank you so much for quickly accepting our request and being there in our conference and delivering such an insightful talk. Thank you once again. Thanks to Sachinandan sir for making a quick connection with you. Thank you.
Yeah, thank you so much, ma'am. Thank you for inviting me.
Thank you, ma'am.
Thank you.
Yeah.